So this is pretty typical of how these projects usually go. You get involved and the first part of it is learning about the piece of equipment that you're working on, and you start off doing some troubleshooting and trying to gather information about what might be going on in the circuit. And as you get deeper and deeper into that, the evidence kind of leads you in a number of different directions, and that's what's happened with this pinball machine. I do have the thing partially working at this point, but I've been down many different roads, and there was quite a lot of learning. This pinball machine came with quite a bit of information. There was a whole printed out manual on how to troubleshoot pinball machines in general. And the problem was that this documentation was a little bit scattered, and it was fairly general because there are a lot of different pinball machines out there. I didn't have manuals that specifically applied to this model. There was pieces of information in there that talked about this model, but not anything definitive. And the schematics, although there were a number of schematics, ranged from very old machines that don't use microprocessors at all to ones that do and had video displays and stuff. This one falls in the middle because it actually had microprocessors or microcontrollers, but it also had a lot of discrete relay logic in it as well. It's kind of a hybrid. And so finding the exact schematics for that were very difficult. Also, the relay logic in there, I mean, it's 40 years old, and they're open contacts, so there was an awful lot of oxidization on those contacts, and there needed to be some cleaning done. A lot of the contacts that allow you to score are behind these little rubber bumpers. The ball comes down, it hits this rubber bumper, and behind there is a contact. When it pushes it in, the contact is made, and it increments your score. Well, a lot of these bumpers, they're kind of a thick rubber band, and they've dried out a lot, and some of them are cracked a little bit. There's actually one here that was broken and came out, and so when I got the machine, there was some of those bands that are included. I'm not sure exactly what I've got yet, but I think I have what I need to replace at least the ones that are in real bad shape. The other thing is that there's the light bulbs here. I've got to get a bunch of those. Those are GE44 bulbs. What the spec says that they're 6.3 volts AC. I needed at least 20, maybe 30 of them, and I found them on Amazon for $3 each Canadian, but you can also buy LED replacement bulbs that'll work. They're specifically made for this, and they're $1 a piece. So I decided to order up 80 of the LED bulbs, and it was about the same price as it would have been for about 25 of the old style bulbs. And the LEDs should last a lot longer and work better, I would think. The other thing is that these sockets are really not very good. They're kind of intermittent, and I'm not sure whether just spraying them with contact cleaner will be enough. I have sprayed most of the ones up on this panel, but there are other ones that I've tried spraying, and they may or may not be reliable enough. I have to try them all again and go through them. Some of these contacts are out of adjustment, and you have to hit this band harder in order to get them to switch. This is an old contact burnishing tool that I picked up somewhere many years ago. It's just like a really fine file. It does take oxidation off quite nicely. All of these seem to be working, but you just never know how long they're going to keep working. So while I was putting in the new light bulbs, I wanted to make sure that the sockets were in good shape and we wouldn't have any contact problems. So a couple of things I did in each one. I had a small burnishing tool that I found, and it's a little bit coarse for this application, but I just used it in a lightweight. It's almost like a Q-tip with a bit of sandpaper adhered to the end. And so what I did was basically on each one of these lights, I just put it in and I just worked it around a little bit just to kind of clean up the inside. I didn't want to go too heavy on this, but just try and get any oxidation off that I could. And then basically I just gave it a little shot of contact cleaner and wiped out the mess that was left. And then I just put the lights in, and that seemed to work in pretty much every case. As you can see here, I got all the rubber bumpers and bands in where they were supposed to go. So the next step was the flippers. Now I've changed one of these already, and I'll show you how I changed the other one. This one here is the one I changed, and the one that was in there was actually broken. Once I took this band off, you could see that the top was broken. And you'll notice that there isn't much play in the movement of this, whereas the other one, there's actually quite a lot of play there. So I think this one still needs to be replaced as well. And fortunately, they had included 2 used but serviceable of these flippers in with the parts that they sent me. And so I'm going to put that in now. Here's the flipper, and you can see that the rubber band around here is quite discolored and it's a bit dried out. So here's the underside, and this is where the flipper shaft comes down into here, and there are 2 Allen bolts there. Those have to be loosened off, and then you can get the flipper out and you can reposition it. Well, it looks like it's just basically loose in there, and I think I can tighten it up just by tightening this screw. Yeah, that seems to have done the trick. So I think I'm just going to put it back in rather than replace it. Okay, I've got the shaft down in there now. I need to align it over here, make sure it's in the right spot. I think that's pretty close. So I've been playing this game to make sure that it actually is working right. And one thing I found was that when the ball was bouncing off the pop bumpers, after a while, the whole machine would just reset. It would just shut down. It didn't tilt, but it just stopped working. And so I started looking further, and I found that the more you use those pop bumpers, the sooner it would shut down. So I started looking at them, measuring the voltages to them. There's several little boards that drive those pop bumpers. And I checked the voltages on there. Everything seemed to be the same and okay. But I thought I better check the voltages on the actual solenoids that run those. When I started measuring on the leads of the coils for those solenoids, I found an interesting thing. There are 3 pop bumpers, and the middle one is right here. The coil is right there, and these are the 2 terminals. And across there, it's difficult to see, but there's a diode there, and it's put there to stop back EMF spikes. Here's the one end of it, and you'll notice that the connection on that end is loose. Now, I don't know for sure that that's the source of the problem, but it could very well be, because every time that pop bumper goes, it shakes this thing. There's quite a bit of vibration to it. And so it could be bumping that enough that we could be getting spikes, and this could be resetting something in the circuit. So I'm going to try and resolder that and see if that makes a difference. Because it was corroded, I took a wire brush to it first. Now I'm putting some flux on it. Probably going to have to clean that up a little bit just to make sure that it did take. I don't think I got it. It appears to me like there's been some soldering done on this before. And I've seen it in some other spots where it didn't look like it was very well soldered. It looks pretty good. I think I'll leave it. So a few more days have gone by. Starting back at the beginning, there were a lot of problems with this pinball machine that were minor, that had to be fixed, and a lot of them were intermittent. As I cleaned up some of the problems, the pinball machine started working better, and I got it to the point where I could actually play the game, and everything was working except for one lamp that needs a transistor replaced. But I would play it for a while, and then all of a sudden the ball would fall back into the hole area and it wouldn't be ejected out. There's a thing called a kicker in there that kicks the ball back out so that you can pull the plunger handle and start your next game. And as long as you've still got plays on the scoreboard, you should be able to continue. The kicker should kick the ball out, but it wasn't doing that. And you could play for a minute and it would do this, or you might play for 5 or 10 minutes before it would do it. And it was just very confusing where this was coming from. In the end, I asked a friend of mine who's worked on pinball machines before to drop around and give me a hand with this, and we kind of worked on it together for a while. And it was interesting because we finally narrowed it down that that kicker was not triggering when it was supposed to. And so we started measuring some things on that and finally found the answer. So here we are. This is the kicker solenoid right here. And when that solenoid is pulled in, it brings this hammer over and it hits the ball, and the ball is sent up the chute, and it's then ready to be shot out into the machine. So the way this works is when the ball goes down in here, it actually closes a contact. The contact sends a signal to the computer, and the computer then sends a signal out to cause this kicker solenoid to pull in. And what was happening is the game would go for a while, and then the ball would come back down in here, it would sit there, and the kicker would not kick in. So after much discussion with my friend, it seemed pretty clear that the kicker solenoid, this solenoid right here, was not pulling in when it was supposed to. The question would be, was it not getting a signal from the computer to pull in, or was there something in the wiring past that, or was the solenoid itself faulty or intermittent? It was difficult to determine that without some kind of a test. So I went back to the schematics I had, which are pretty limited in their clarity, and after looking more closely at them, I came to the conclusion that there was one part here that talked about controlled solenoids and also relays. And so this wasn't specific. This was just a diagram showing a typical circuit for controlling solenoids, and that solenoid would be one of them. And you can see here that there's a fuse here, and then there's a solenoid with a diode across it, and then we've got the line going out to this transistor here, and the emitter of this NPN transistor is connected to ground. So basically what's happening is that transistor is getting a signal from the driver board when it's supposed to pull in that solenoid. So the question is there a problem getting the signal, or is there a problem with the transistor? Is there trouble with the wiring on the way back? Is there trouble with the solenoid? Is there trouble with the fuse? So we decided first of all to check on this side of the solenoid to see if it had the voltage. It's supposed to be 24 volts on there. So I connected one lead to the solenoid, and I connected the other one to the circuit ground, and I got 24.47 volts. So that seemed good. I decided to try and simulate the transistor turning on. Basically what I did was I went back to the control board, and after looking at that schematic and the parts list, I came to the conclusion that there were 3 transistors that turned on these kinds of solenoids. There was a transistor here, and transistor here. There's a bunch of other transistors in there that turn on and off the lights, and there's 3 other transistors that turn off some other coils. But I knew it had to be one of these 3. So basically all I did was I took a wire from the ground, this is connected back to the ground of the power supply, and I went to each of these and I touched their collector, which was basically shorting out to ground across the transistor. And you can hear it, that sound that you heard was the kicker kicking in. So that was working. So we knew the solenoid was working. But we also knew that it wasn't working all the time, because it would work for a while and then it would quit. So we decided to start playing the game until the solenoid no longer was working again, which would happen every time after a while. And what we found was that that voltage that we had been measuring on the solenoid was dropping from 24 volts down to 5 volts. Now, here are those fuses, and there's even a nice handy list. It says F10 is a 1 amp slow blow fuse for the out hole. The out hole is where that solenoid is located. So that's F10, which is this one on this end, and I measured on this end, and I was getting 24 volts. I measured on this other end down here, and I was getting 5 volts. So I just pulled out that fuse, stuck in a new one, sprayed the fuse holder, and readjusted it to make sure it was tight, and put in the new fuse, and things started working. So that was pretty much the last major step in getting this pinball machine working. I did do a bit more cleaning up of the play field and inside the bottom part of the enclosure. I re-cleaned some contacts, made a few adjustments here and there, and obviously I had to do some extensive testing on this machine. It was kind of fun doing that part. And I have to be honest though, there still seemed to be a small gremlin in this thing at the end. Occasionally after playing a game, when I would put in another quarter, it just wouldn't sense it. And I would have to turn off the machine and turn it back on. And I don't know exactly what was causing that. But unfortunately, I don't have the machine any longer. In retrospect, I do wonder if the contacts in the Q relay were still maybe not reliably making contact. They maybe needed a little further cleaning or a little further adjustment. But I don't have it here, so I can't test that. Still, the machine is very playable, and hopefully will keep providing enjoyment for a long time for the owners. I would like to thank the owners for allowing me to work on this. It's my first time on a video game. I learned a lot and enjoyed it a lot. And I also want to thank my friend Brad, who brought this thing to me to fix. So I did enjoyed the project a lot. I learned a lot, and I do hope the owners have a lot of fun with the game in the future. That said, it is an old machine, and short of replacing a lot of fairly expensive and somewhat hard to obtain parts, I wouldn't be surprised if a few issues do crop up in the future. So anyways, I'm going to wrap up this series right here, and I would encourage you to like and subscribe if you got something out of this that you enjoyed. Please do leave a comment or a question. I'll try and answer that as best I can. I'm not an expert on video games, and often some of the projects I get, they're my first time on it, so I don't always know everything about the whole system that I'm working on, and so I can't always answer your questions completely. My approach to all of this is just that I try and mix some technical knowledge, some background and troubleshooting experience, with some common sense, and probably the biggest thing is just tenacity, keeping at it until I find a solution. Sometimes I'm successful, sometimes not, but it's always interesting. So thanks again for watching. I'm hoping to get some more videos out to you pretty soon, and we'll see you on the next one.